Buckle up, space enthusiasts. We're diving deep into a mission that's going to blow your mind.
Ooh, I'm intrigued already.
Today's all about SPHEREx.
SPHEREx.
It's aiming to create the most incredible, the most comprehensive 3D map of the entire universe.
Wow.
And the craziest part? They're doing it all with an observatory the size of a small car.
Seriously? A small car mapping the entire universe? That's amazing.
It is, right? Talk about ambitious. It's launching in February 2025.
So it's not far off at all. Can you give us a little taste of what SPHEREx will be looking at?
Absolutely. Get this. Hundreds of millions of galaxies and stars.
Hundreds of millions. That's incredible.
But it gets even better.
Okay. Well,
It's not just capturing them in plain old color. SPHEREx is going to observe them in 102 different wavelengths of light.
102. Whoa, that's a lot of data.
It is. It's mind-boggling just thinking about it. All that data to paint the most detailed picture of the universe we've ever seen.
It really does sound like a game changer. I mean, to see the universe in that level of detail.
Right. So let's talk about why. What big questions is SPHEREx designed to answer?
Well, one of the primary goals is to tackle a real head-scratcher. Inflation. You know, that crazy period right after the Big Bang when the universe went boom.
Inflation, yeah. It's like the universe hit the fast-forward button on expansion. I can't even wrap my head around it.
Right, and nobody really knows exactly how or why it happened so fast. But SPHEREx might have the answer. By studying the distribution of galaxies, it could help us understand what fueled that rapid expansion.
So like looking for clues in the way galaxies are scattered across the universe.
Exactly. It's like looking for cosmic breadcrumbs that lead back to the very beginning of, well, everything.
That's incredible. We could be looking back to the first moments of existence.
That's the hope. And that's not all. SPHEREx will also be teaching us a lot about the present-day universe.
Like what? Fill us in.
Well, there's a lot we still don't know about the galaxies we can already see, right? But there are also tons of galaxies hidden from our view, obscured by cosmic dust.
Oh, hidden galaxies. That's a new one.
They're out there. And SPHEREx is going to help us find them. It's going to measure the collective glow of all galaxies, even the faintest ones.
I get it. So we're not just seeing individual galaxies, but the combined light of everything out there.
Exactly. And that's going to give us a much more complete picture of the universe's structure and how matter is distributed within it.
Wow, it's like taking an X-ray of the universe. So we've got SPHEREx peering back to the beginning of time and revealing hidden galaxies. But hold on.
Is there more?
There's more. SPHEREx also has a down-to-earth mission. The search for the building blocks of life.
Now that's what I'm talking about. I knew it had to tie back to the search for life somewhere out there.
Right. It's incredible. SPHEREx will be scanning our own Milky Way for something pretty special.
What's that?
Icy granules packed with water, carbon dioxide, and other essential molecules for life as we know it.
So like the ingredients list for life itself.
Exactly. By mapping where those compounds are and how much there is, we get a better idea of how likely they are to end up in new planets.
Okay, I'm starting to see the big picture here. SPHEREx is tackling these massive universal questions while also helping us understand the potential for life elsewhere.
It really is a bridge between these mind-blowing cosmic scales and the search for life. But how does it actually work? How do you map the universe from a small car-sized observatory?
Well, it all comes down to the magic of spectroscopy.
Spectroscopy. That's a mouthful.
It's simpler than it sounds. It's essentially the art of dissecting light.
Dissecting light. Okay, you got my attention.
Imagine shining light through a prism. It separates into all the colors of the rainbow, right?
Right. I remember doing that in school.
Well, that's what spectroscopy does. It splits light into its individual wavelengths. And by analyzing those wavelengths, we can learn a ton about the object that emitted that light.
So each wavelength is like a secret message about the object.
You got it. And SPHEREx is equipped with a super high-tech tool, a spectrophotometer, that measures the intensity of light at those different wavelengths.
So it's like a cosmic code breaker. That's super cool.
It is. It's deciphering messages hidden within starlight. But hold on, there's another piece to the puzzle.
Let's hear it.
We need to go from analyzing starlight to creating that 3D map of the universe.
Right. How do we do that?
Enter redshift. It's all about the way light behaves as objects move in space. Imagine an ambulance speeding away from you. Its siren sounds lower pitched, right?
Yeah, because the sound waves are stretching out as it moves away.
Exactly. Light does the same thing. When an object in space moves away from us, the light it emits gets stretched, shifting towards the red end of the spectrum. The faster it moves away, the greater the redshift.
So by measuring how redshifted a galaxy's light is, we can tell how far away it is.
You got it. And by combining that distance information with the galaxy's position in the sky, we can pinpoint its location in 3 dimensions. It's like cosmic GPS.
Wow, it's amazing how something as subtle as the stretching of light can tell us so much about the universe.
And remember those hidden galaxies we talked about? Well, their combined light creates a faint background glow.
Right, like a faint cosmic hum.
Exactly. And by analyzing the redshift of this glow, we can even map those hidden galaxies, giving us a truly complete picture of the universe's structure.
It's like we're seeing the universe for the first time with SPHEREx. It's incredible.
And we're just getting started.
I can't wait to hear more. But before we go too deep, let's take a closer look at how SPHEREx tackles the challenge of mapping the entire sky. What makes its approach so unique?
Well, one of the biggest challenges is the sheer amount of data involved. Billions of stars and galaxies, each with its own spectrum to analyze.
Billions. That's overwhelming just to think about.
It is. But SPHEREx has a trick up its sleeve. It uses a technique called spectrophotometry, which basically allows it to capture the entire spectrum of light from a wide area of the sky all at once.
So instead of looking at objects one by one, it takes a big panoramic snapshot, grabbing the spectra of tons of objects simultaneously.
You're getting it. It's a much faster way to survey the entire sky compared to traditional telescopes.
That's super efficient. But how does it make sure it's capturing everything accurately when it's all crammed into one big image?
That's where SPHEREx's amazing optics come in. It uses lenses and mirrors to split the incoming light into its different wavelengths and then focuses that light onto an array of detectors.
So it's like a giant prism inside the observatory.
You got it. And each detector is responsible for measuring the light intensity at a specific wavelength.
So we get a detailed spectral fingerprint for every object in the image.
Precisely. It's pretty amazing how they've packed all that technology into a small, car-sized observatory.
It's mind-blowing. And we've only just scratched the surface of what SPHEREx is capable of.
I know, right? And the really exciting part is what we might discover with all that data.
Exactly. And that's what we'll be diving into next time. We'll explore the potential discoveries SPHEREx might make, especially when it comes to the search for life's building blocks.
I'm ready for more cosmic revelations.
Me too. It's going to be amazing.
Yeah.
Until then, keep looking up and stay curious, everyone.
Welcome back. Ready for more SPHEREx?
Oh, absolutely. Last time, we covered how it works and its ambitious goals. But now I'm curious. What kind of groundbreaking discoveries could this mission realistically make?
Well, let's start with that crazy period right after the Big Bang. Inflation.
Ah, yes. Inflation. That's still a mind-boggling concept.
It is, right. That massive expansion.
Yeah.
Current theories point to various things driving this, and one is something called the inflaton.
Right, the inflaton. I've heard of it, but it's still pretty abstract to me.
Think of it like an energy field that basically permeated the very early universe,
Okay.
and it caused the universe to expand at an exponential rate.
So SPHEREx's detailed map of galaxies, could it actually reveal patterns from that?
Exactly. Almost like ripples, but frozen in the fabric of the cosmos.
Like an imprint of the expansion.
Yeah.
Could we actually see the inflaton's influence?
That's the idea. By analyzing those patterns, SPHEREx could either support the inflaton theory or even show us completely new physics at play.
Whoa, potentially rewriting the very beginning of the universe.
It's a possibility. But let's shift to the universe as we see it today.
Okay, what could SPHEREx uncover about the galaxies around us right now?
This is where those hidden populations of galaxies come in.
Right, those obscured by dust, the ones we can't see.
SPHEREx's ability to measure that collective glow, even from those faint hidden galaxies.
Yeah.
It could reveal entire clusters of galaxies we've never even detected before.
Could those hidden galaxies be fundamentally different?
That's a great question. They could be. They may have formed differently, evolved under totally different conditions,
Interesting.
or even be made of something we don't know yet, some exotic matter. Studying them could really challenge what we think we know about galaxy evolution.
So SPHEREx could rewrite the textbooks again. Okay, I want to hear more about its role in searching for life's building blocks.
Now we're talking. This part of the mission really is exciting. SPHEREx is going to be looking for very specific spectral signatures.
Okay.
Signatures of molecules like water, carbon dioxide, methane.
The essential ingredients for life.
Exactly. It's like searching for fingerprints, but at the molecular level.
So we're looking for signs of water, carbon dioxide, methane.
Yep. And it's not just finding them. It's about mapping their distribution, seeing how abundant they are across the Milky Way.
Are we basically hoping to find areas where they're really concentrated?
Yes. Identifying those regions could guide future missions, tell us where to focus the search for life.
So SPHEREx is creating a treasure map of sorts.
That's a great way to put it. It's showing us the most likely places to find those crucial ingredients for life.
But wouldn't finding these molecules also tell us something about what conditions are needed for life?
Absolutely. By studying where they cluster, we can figure out the environments where they're most likely to form and stick around,
So we're learning not just about where life might exist.
but also how life might come to be. SPHEREx is tackling both of those questions.
It's incredible. But let's zoom out for a second. What are the bigger picture implications here? How could SPHEREx impact our understanding of the universe as a whole?
Now we're getting philosophical. SPHEREx could change our grasp of fundamental physics, and one area is those mysteries. Dark energy and dark matter.
Dark matter and dark energy. There's still such enigmas
Right. We know they exist, they have to.
because of their gravitational effect.
Exactly. But their true nature, what they are, it's still a huge mystery.
And SPHEREx could help with that.
Yes. SPHEREx's map, with those precise measurements of distances and redshifts,
Right.
that could help us narrow down the possibilities, constrain the properties of dark matter and dark energy.
Potentially huge insights there.
Exactly. It's like unmasking some of the universe's deepest secrets, but think about it on a philosophical level, too.
Okay.
What could SPHEREx tell us about our place in the universe?
It's a question that humans have been asking forever, isn't it?
It is. But by mapping the vastness and potentially showing how common life's building blocks are,
Right.
SPHEREx could challenge our ideas about how special or unique we are,
It's humbling to think about the sheer scale of it all.
and the possibility that we're not alone.
And wouldn't that realization also make us feel more responsible for our own planet?
I think so. If we're not unique, the need to protect our pale blue dot, it becomes even more urgent.
It's definitely a powerful perspective.
And there's something else to consider. This mission, as grand as it is, could lead to more down-to-earth benefits, too.
How so? How could studying distant galaxies help us here?
Think about it. The technology developed for space often ends up being used elsewhere.
Right, spin-off technologies.
Exactly. The advanced sensors and data analysis from SPHEREx, those could lead to innovations in other fields.
Like what?
Well, things like medical imaging, environmental monitoring, maybe even telecommunications.
So the quest to understand the cosmos can have practical benefits for our daily lives.
Absolutely. When we push the limits of technology for space, those advancements often find their way back to Earth, benefiting all of us.
It's a cosmic ripple effect.
Exactly. That's one of the most compelling things about space exploration. It's not just satisfying our curiosity, it's about pushing the limits of what we can achieve.
And using that knowledge to improve our lives and understand our place in the universe.
Beautifully put. This has been an amazing discussion about SPHEREx, its potential discoveries, and what those discoveries could mean.
It really has. SPHEREx is poised to reshape our view of the universe. But before we wrap up, I think it's important to bring it back down to Earth, so to speak.
I agree. What do you mean?
Let's talk about the people behind the mission, the brilliant minds making this incredible endeavor possible.
That's a perfect transition. After all, it's the dedication and ingenuity of all those individuals that makes a mission like SPHEREx a reality.
Welcome back to the Deep Dive. We're wrapping up our SPHEREx journey today. We've covered so much ground, from the Big Bang to the potential for life elsewhere.
It's been a wild ride.
It has. But I think there's one more crucial piece to this puzzle.
Oh.
The human element. We've talked a lot about the science and technology,
Right.
but it's easy to forget that behind all of this is a team of incredibly talented and dedicated people.
Absolutely. We've talked about the incredible tech, but it's those minds that bring it all together, you know?
Exactly. SPHEREx is a testament to human ingenuity, collaboration, perseverance.
It really is. Think about the sheer scale of this thing. You've got astrophysicists, engineers, computer scientists, countless others all working together to make this happen.
A true symphony of human talent,
Right.
all driven by this shared desire to understand the universe.
And it's not just about technical skills, right? You need immense creativity to solve the problems that come up, to push the boundaries of what's possible.
It's that human spirit of exploration, the relentless pursuit of knowledge. And that's something that goes beyond borders and cultures, doesn't it?
It does. SPHEREx, like so many space missions, is a truly global effort.
Teams from all over the world.
Different backgrounds, disciplines, all coming together, sharing their knowledge, and working towards this common goal.
It's amazing to see what we can achieve when we pool our resources and expertise like that.
It really is. But it's also important to remember the individual stories, those personal journeys of the people behind it all.
Right. Each person brings their own unique perspective, their own passion.
Yeah. And there are so many untold stories, late nights, dedication, all fueled by this dream of discovering something incredible.
I bet the sense of fulfillment must be immense.
Oh, I'm sure it is. To know you're contributing to something that could fundamentally change our understanding of the universe, that's something special.
And the impact, it goes beyond the scientific community, right?
It does. Missions like SPHEREx inspire the next generation of scientists, engineers, explorers.
Absolutely. They show us that anything's possible if we dare to dream big.
And that inspiration, it spreads outwards. It creates this sense of wonder, of curiosity about the universe and our place in it.
It's about fostering that spirit of exploration, not just in space, but in everything we do.
Yes. Encouraging people to ask questions, challenge assumptions, never stop learning.
I think that beautifully captures the legacy of missions like SPHEREx. It's not just about the data, it's about that human drive to explore, to understand, to push the limits of what we know.
Well said. As we wrap up our deep dive into the world of SPHEREx, I hope we've given you a glimpse not just of the science, but of the heart and soul behind it.
The people who make it all possible, their dedication, their brilliance, their unwavering pursuit of knowledge.
It's inspiring, isn't it?
It truly is. And as we get closer to SPHEREx's launch in 2025,
Not long now.
I think we can all be excited about the incredible discoveries it might make and the amazing testament to human curiosity and our desire to learn that it represents.
Beautifully put. And remember, the universe is full of wonders waiting to be discovered, so keep looking up, keep asking questions.
And never stop exploring. This is The Deep Dive. Signing off for now. Until next time, stay curious.